in the Flesh is back, and we are back with magnetic force on moving charges. Happy New Year, by the way, to those of you who celebrated, and thank you so much for your patience, as I know it's been a while since I posted a video. This year has been considerably more busy for me in terms of my work, so it's taken me some time to get back to this, but thank you for those of you who have subscribed, for those of you who are just watching. Continue to stay tuned. I'll be posting videos as much as I can over the next little while. So let's jump into this problem. The charged particle below moves east. It experiences a force that acts into the page. Does the particle have a positive charge or negative charge? So when it comes to these magnetic force problems, you have some vectors, right? Some quantities that have both magnitude and direction. And specifically, those quantities are magnetic force and the velocity of the particle. Now, velocity of the particle, sometimes you can also look at that in terms of the current. Okay, something is moving in a certain direction. Now, the other item that is a vector, that has a magnitude and a direction, is the magnetic field. So these three things, magnetic force, velocity, and magnetic field, they all have to be perpendicular to each other. So physicists came up with something called the right-hand rule. And what the right-hand rule tells us is, while using your right hand, you arrange your fingers in such a way that three fingers are all perpendicular to each other. So if I go like this with my fingers, notice that my thumb is perpendicular to my index finger, which is perpendicular to my middle finger, which is again perpendicular to my thumb. So all three of these are perpendicular to each other, just like the Z, Y, and X axes in the three-dimensional context. Okay, so based on this problem, okay, let's set this up. So it says the particle moves east. Now, the direction in which you're moving is the direction of your velocity. So let's say the particle, we consider it to start there. It's moving east, so based on our diagram, it's moving in the positive y direction. Okay, so this is the velocity of our particle. We're told it experiences a force that acts into the page. So we got to figure out whether the particle has a positive or negative charge. Now, something that wasn't written in the question but is actually given is the direction of the magnetic field, and that is going in the positive z direction. Now, to symbolize the force is going into the page. Now, there's two ways to represent this. This symbol means into the page, and this symbol means out of the page. And the analogy that most people use is, well, it looks like an arrow. If the arrow is heading towards you, you see that little point of the arrow just shooting out, right? And if the arrow is going in, well, this is like the crosshairs at the end of the arrow going into the page. Okay, so into, out of. So here, the force is acting into the page, so we would put an X. Now we got to figure out if this particle is positive or negative. So this is how you do it. Memorize this. It's going to work for you every time. What you want to understand and remember is that your thumb, let your thumb be the magnetic force. Your index finger is going to be the current of a positive charge for the velocity of the particle. And your magnetic field is going to be your middle finger. Okay, so I didn't write that in the same order, but that's okay. So thumb, magnetic force, index finger, the motion of your particle, and the middle finger is your magnetic field. So remember that. But what you have to remember is this is only for a positive charge. Okay, so this rule is for a positive charge only. Now we have to figure out if this particle has a positive or negative charge. We're given the direction of all three of these things: force, magnetic field, and speed, or the velocity, the motion direction. So if my fingers, based on what I've written here, match the directions given in the problem, that means it's a positive particle. But if just one of these is in the opposite direction, that means it's not positive, it's negative now. Okay? So I'll show you what I mean. Okay, so thumb is magnetic force, index finger is the direction of motion, the velocity, and my middle finger is the magnetic field. Okay, so here we go. My velocity is going in this direction. So here we go. So my index finger is going to go like that. Okay, my magnetic field, which is my middle finger, is going up. So velocity, magnetic field, it's like this, right? So which way is my thumb going? My thumb's going out of the page, right? oops, let me angle this so it's more in line of the camera. My thumb's going out of the page, which means it's not matching with this picture. In the picture, it's showing the force to go into the page. But if I put my index finger in the direction of the velocity, my middle finger in the direction of the magnetic field, so it's hard to angle it like that, then my thumb points out. It doesn't point in. So a positive charge that's moving in this direction due to this magnetic field experiences a force out of a page. So since the force is actually going into the page, that means it has to be a negative particle. Now, you clearly saw how hard that was for me to angle my hand, and I'll be honest, it wasn't that comfortable for me on this end either. I'm going to level with you guys. I don't always use the right hand rule like that. In fact, for me, it's more convenient to do something else. While I was studying for my midterms in university, I actually came up with the rule, and I'm sure I'm not the first person, 100% sure I'm not the first person to come up with this, but something that made sense to me. And I'm sure a lot of other people use it too. This is how I do it. Now, if it's too confusing for you or you think it's silly and it's even more complicated, then, don't use it. Use what I just showed you. That's the standard rule. But if this actually makes it easier for you, feel free and use it. Okay, so this is how I do it. The right hand rule, I modify like this. If you see these associations I made for the different fingers of the right hand, if everything matches on the right hand, then I consider it to be a positive charge. But if I can match these things to my left hand, now I consider it to be a negative charge. Now I'll give you an example. This question, you see how it turned out to be negative? I'm going to show you how it's going to work much easier without you having to twist your hand in a weird way. Okay? If these fingers match your negative hand, it's a negative particle. If these fingers match your right hand, it's a positive particle. Now, same thing. Your thumb represents magnetic force. So here's my left hand. Thumb represents magnetic force. Index finger is the velocity. Middle finger is magnetic field. And notice again, they're all perpendicular. So here we go. You see the velocity? It's going east. East. My my middle finger's in the direction of magnetic field. So it's going up. Which way is my thumb going? Into the page. Now, okay, true. You're probably looking at this and saying, okay, yeah, that looks pretty uncomfortable. And it is. Fair enough. That was pretty uncomfortable. You will find some situations in which it is more comfortable, but regardless, you have two ways of doing it. You can use left hand for negative particles, right hand for positive, or you can simply notice that if it's the opposite direction that you're getting from the right hand rule, that means it's a negative charge. So whatever way is easier for you, use that method. But guys, that's it for this video. Hope you enjoyed it. As usual, be sure to smash that like button if you liked it, and subscribe to Physics in the Flesh so you never miss a video from me. Anyways, guys, stay tuned next time for video 173, Magnetic Force on Moving Charges 2, where we manipulate the magnetic force formula. Stay tuned, guys. Talk to you later.